Imagine this. You step outside a spacecraft. No suit, no protection, no warning. Just you and space. What happens next? Most people think you'd explode. Some think you'd freeze instantly. Others imagine a dramatic, cinematic death, loud, violent, immediate. But nature doesn't work like the movies. Space is not trying to kill you. It's simply indifferent. And that makes it far more dangerous. Because nothing grabs you. Nothing pushes you. Nothing even makes a sound. There's no air to scream through. No pressure to hold your body together. No warmth to keep your cells alive. Just emptiness. And in that emptiness, something very strange happens. You don't die instantly. For a few seconds, you're still conscious, still thinking, still aware that something is terribly wrong, which raises a much more unsettling question. If you had no clock, no one to tell you, how long would you actually survive? Not in theory, not in movies, but in reality, because the answer is not what you expect. And it reveals something much deeper, not just about space, but about how your body and the universe really work. What actually happens the moment you enter space? Let's begin at the exact moment. You are standing at the edge of a spacecraft. There is air behind you, pressure, warmth, sound, and in front of you nothing. No air, no pressure, no resistance, no medium for anything to travel through. You step out, and the first thing that happens is nothing dramatic, no explosion, no instant freezing, no violent tearing of your body. In fact, for a fraction of a second, you might feel almost normal because your body doesn't fail instantly. It begins to fail, and the difference between those two things is everything. Now, here's the first critical mistake people make. They imagine that in space, the lack of pressure causes the body to burst like a balloon popping. But your body is not a balloon. Your skin is strong, elastic, designed to hold internal pressure differences far greater than what you might expect. So you don't explode. But something else happens. Something quieter and much more dangerous. The moment you are exposed to vacuum, the air inside your lungs becomes a problem. Because inside your body, the pressure is still normal. Outside, it's almost zero. And nature always tries to equalize pressure. So if you're holding your breath even slightly, your lungs will expand rapidly. Not because something is pulling them outward, but because there is nothing pushing back. This can cause serious damage. So the first instinct to hold your breath is exactly the wrong thing to do. If you don't exhale immediately, your lungs can rupture. Air can leak into places it shouldn't. And this alone can become fatal very quickly. Assume you do exhale. You let the air leave your lungs. Now the pressure difference is still there, but the immediate danger is reduced. And now the second phase begins. The fluids inside your body begin to react. Because pressure doesn't just affect air, it affects liquids too. At normal atmospheric pressure, water boils at 100 degrees Celsius. But lower the pressure, and the boiling point drops. Lower it enough, and water begins to boil at body temperature. You are not getting hotter. Your blood is not heating up. But the pressure around you is so low that the liquid inside your tissues begins to form vapor bubbles. This process is called ebullition, and it starts within seconds. Your saliva begins to bubble. Your tongue feels like it's fizzing. The moisture in your eyes starts to evaporate. Your skin begins to swell, not explode, but expand slightly as gases form in your tissues. You might inflate to about twice your normal size. Uncomfortable, disturbing, but still not immediately fatal. Now, all of this is happening within the first 5 to 10 seconds. And here's the most important part. You are still conscious. You are aware. You can think. You can observe what is happening to you, which is what makes this so unsettling, because your body is failing, but your mind hasn't caught up yet. At the same time, something more critical is happening. Your blood is no longer carrying oxygen effectively, not because the oxygen is gone instantly, but because the pressure that keeps gases dissolved in your blood is dropped. Oxygen begins to leave your bloodstream. Carbon dioxide behaves differently, and its imbalance creates confusion in your brain. Within about 10 seconds, you begin to feel lightheaded. Your vision starts to narrow. Not black immediately, but dim. Like the edges of your perception are fading. At around 12 to 15 seconds, you lose consciousness. Not dramatically. No sudden blackout. Just a gradual slipping away, like falling asleep without realizing it. Your brain simply does not have enough oxygen to continue functioning. And this is the key point. You don't feel yourself dying. You stop being aware before that experience fully forms. Now pause here, because most people imagine death in space as something painful, violent, overwhelming. But the reality is quieter, more mechanical, more indifferent. Your body is not being attacked. It is simply failing to operate in an environment it was never designed for. Now let's go slightly deeper, because even after you lose consciousness, your body is still undergoing changes. Your heart may continue beating for a short time. Your cells are still alive. But without oxygen, without pressure, without regulation, the systems begin to shut down, irreversibly. However, and this is important, this is not instant death. If you were rescued within about 60 to 90 seconds, you could potentially survive, not unharmed, but alive. There have been cases, rare, controlled, but real, where exposure to near vacuum did not immediately kill a person. Because the body is surprisingly resilient, it doesn't break instantly. It degrades. But beyond that window, damage becomes severe. Brain cells begin to die from lack of oxygen. Circulation fails, and recovery becomes unlikely. Now let's talk about something people often get wrong. Freezing. You might think that in space, you freeze instantly. After all, space is cold, extremely cold. But temperature is not just about how cold something is, it's about how quickly heat is transferred. And in space, there is almost no medium to carry heat away. No air, no convection, only radiation, which is a slow process. So you don't freeze instantly, not even close. Your body retains heat for a while. In fact, the boiling of fluids happens before freezing becomes relevant. So the sequence is not freeze death. It's loss of pressure, gas expansion, oxygen deprivation, unconsciousness, eventual failure. Cold comes later, much later. Now let's step back and look at what we've learned so far. Within seconds, pressure drops, air leaves your lungs, fluids begin to boil, your body swells. Within 10-15 seconds, oxygen levels fall, vision fade, consciousness is lost. Within 1-2 minutes, irreversible damage begins. And throughout all of this, there is no sound, no wind, no sensation of being attacked, just silence, and a body that can no longer function. But this is only the beginning, because everything we've described so far assumes one thing, that you are just floating in space. But space itself is not empty in the way people imagine. There is radiation, there is sunlight, there are extreme temperature differences depending on where you are. And those factors introduce a completely new set of dangers. In the next part, we'll go further. We'll look at what happens if you remain in space longer, not seconds, but minutes, and what the environment itself begins to do to your body. Because the real story is not just how quickly you lose consciousness, but what space does to you if you stay there. What space does to you after you lose consciousness. Now imagine something unsettling. You are no longer conscious. Your body is floating in space. No movement, no control, no awareness. But the environment around you is still acting on you. Because space is not empty. It only looks empty. The first thing to understand is that space is full of energy. Not air, not pressure, but radiation, invisible, silent, constant radiation. And without an atmosphere, there is nothing to stop it. On Earth, you are protected. The atmosphere absorbs most harmful radiation. The magnetic field deflects charged particles. Even sunlight is filtered softened before it reaches your skin. But in space, there is no protection, no filter, no shield. If you are exposed directly to sunlight in space, something very strange happens. You don't feel heat the way you do on Earth because there's no air to carry it. No convection, no warm breeze, but radiation still hits you. Energy is still being transferred, and that energy is intense. The side of your body facing the sun begins to heat up rapidly, not evenly, not gently, but sharply. One side of you can become extremely hot, while the other side facing away from the sun remains extremely cold. This is one of the strangest aspects of space. Temperature is not balanced. It's not smooth. It's extreme in both directions at once. On the sunlit side, your skin can heat to well above boiling temperatures. On the shadow side, it can drop far below freezing. At the same time, your body becomes a system of extremes, hot and cold coexisting without mixing, because there's no medium to distribute the heat. Now remember, you are not conscious. You are not reacting. But your body is still undergoing these changes. Cells are being damaged. Proteins are breaking down. Tissues are expanding, contracting, degrading, not because space is attacking you, but because there is no system maintaining stability anymore. Now let's go even further. Radiation, not just sunlight, but cosmic radiation. High energy particles traveling through space at nearly the speed of light. These particles pass through matter, through metal, through tissue, through you. On Earth, most of these particles are blocked or deflected. In space, they hit you directly. And when they do, they don't just bounce off. They pass through your cells, breaking molecules, damaging DNA, altering the structure of life itself. Now, in the short time frame, we're discussing seconds to minutes. Radiation is not what kills you, but it is constantly acting, constantly interacting, constantly changing the structure of your body at a microscopic level. And here's the important part. All of this is happening in complete silence. No sound, no signal, no indication that anything is happening at all, because space does not communicate its effects in ways you can feel. It simply applies them. Now let's consider a longer time frame. Imagine somehow your body remains in space, not rescued, not recovered, just drifting. Minutes turn into hours, hours into days. What happens then? The temperature begins to equalize, but not in the way you might expect. Without internal heat regulation, your body slowly cools. Not instantly, but steadily. The heat you once had begins to radiate away into space. And with no source of new energy, it does not return. Eventually, your body freezes. Not violently, not dramatically, but completely. Every fluid becomes solid. Every structure becomes rigid. You are no longer a dynamic system. You are a fixed one, frozen in place. But even here, space is not done, because freezing is not preservation, not in the way people imagine. Over time, something called sublimation begins to occur. This is when frozen material turns directly into gas, skipping the liquid phase entirely. And in the vacuum of space, this process is accelerated. Molecules slowly leave the surface of your body, drifting away, un by un. This is not fast, not visible in the moment, but over long periods, it changes everything. Your body begins to lose mass, slowly, silently, without any force or event, just a gradual dispersal of matter into space. Now, let's go even further. Months, years, decades. In that time frame, radiation continues to act. Cosmic rays continue to pass through what remains of your body, breaking down molecules, disrupting structures, reducing complexity. The sun, even if distant, continues to emit energy, and that energy continues to interact, heating, cooling, expanding, contracting, again and again. Over long enough time scales, what was once a human body becomes something else, not destroyed in a single event, but transformed through continuous exposure. Now let's step back, because what we're seeing here is something very important. Space does not kill you in the way you might expect. It does not attack. It does not strike. It does not act with intention. It simply removes the conditions required for life, and then allows physics to take over. On Earth, life is supported by pressure, temperature stability, oxygen, protection from radiation. Remove those, and life doesn't end instantly. It just stops being sustained. And once it's no longer sustained, it begins to unravel. Now here's something even more interesting. All of this depends on where you are in space, because space is not uniform. Near Earth, you still have some protection, magnetic fields, residual particles, a nearby star providing energy. But move further out, away from stars, into deep interstellar space, and the conditions become even more extreme, colder, darker, more isolated. And that leads to a deeper question, because everything we've described so far assumes something simple. That space is just a physical environment, a place where things happen. But what if space is more than that? What if the environment itself is part of a larger structure, one that defines not just how things happen, but when they happen? In the next part, we'll go even deeper, because we're going to leave the body behind for a moment and look at something more fundamental, time, and how your experience of survival, even in something as simple as space, depends on how time itself is structured. How long is a second in space? So far, we've been talking about time as if it's simple, seconds, minutes, a timeline. You step into space. 10 seconds you're conscious. 15 seconds you black out. 1 minute damage begins. It sounds precise. It sounds measurable. It sounds like there's a universal clock somewhere counting down, but there isn't. And this is where things start to get strange. Time is not what you think it is. Not in space. Not anywhere. We treat time like a shared experience, like something that flows the same way for everyone, everywhere. A second is a second. A minute is a minute. That's how it feels. But physics tells a different story. Time depends on motion. Time depends on gravity. Time depends on where you are and how you're moving. Imagine two people. One is floating in space. The other is standing on Earth. Both have clocks. Both are measuring the same event. How long does a human survive in vacuum? You would expect them to agree, but they don't. Not exactly, because the person on Earth is deep inside a gravitational field. The planet is massive. It bends space-time, and that affects how time passes. The person floating far away in space experiences time slightly differently. Not enough to notice in everyday life, but enough that, in principle, their measurement of time is not identical. Now take it further. Imagine the person in space is moving very fast, not just drifting, but traveling at a significant fraction of the speed of light. Now the difference becomes real, measurable, significant. From their perspective, time slows down. Not metaphorically, not psychologically, physically. This means something very strange. The same event, your exposure to space, can have different durations depending on who is measuring it. From your perspective, you lose consciousness in about 15 seconds. That's your experience. That's your internal clock. But from the perspective of someone moving very fast relative to you, that same 15 seconds might appear longer or shorter, depending on their motion. So now we have a problem. What does it mean to ask? How long could you survive? Survive according to which clock? Which observer? Which frame of reference? Because in relativity, there is no single answer. There are many valid answers, each tied to a different observer. Now, for practical purposes, the differences are small. We're not moving at relativistic speeds. We're not near extreme gravitational field. So the numbers we gave earlier, 10 seconds, 15 seconds, 1 minute, are meaningful. But the deeper point remains. Time is not absolute, even in something as simple as survival. Now let's shift perspective, because there's another kind of time involved here, not physical time. Experience time. What does it feel like? Those final seconds. You might imagine panic, fear, pain. But remember what's actually happening. Oxygen is leaving your bloodstream. Your brain is losing its ability to process information. So instead of a clear, sharp awareness, your experience becomes distorted. Vision narrows, sounds fade, thoughts become slower, less structured, less coherent. Time itself begins to feel different. A second might feel longer or shorter, not because physics changed, but because your brain is no longer processing time normally. This is something we've seen in extreme conditions. In high-stress situations, in moments where consciousness is fading, the perception of time breaks. So now we have two layers. Physical time measured by clocks, experience time measured by your mind, and they are not the same. In your final moments of consciousness, those 10 to 15 seconds might not feel like 10 to 15 seconds. They might feel stretched or compressed or fragmented. You might not even experience them as a continuous sequence, but as disconnected impressions, and then nothing. Now step back, because something very strange has happened. We started with a simple question. How long could you survive in space? And now we've discovered that the answer depends on who is measuring. The answer depends on how time flows in different frames. The answer depends on how your brain perceives time. There is no single universal duration. Even survival is relative. Now let's take this one step further, because there's something even more unsettling. In physics, time is often treated as another dimension, like space. Instead of thinking of your life as something that unfolds moment by moment, you can think of it as a path, a trajectory through space-time. Your exposure to space, those 15 seconds, is not just something that happens. It is a segment of that path, a fixed part of the structure. From that perspective, your survival is not something that is changing. It is something that is already defined, a segment of your world line. You experience it moment by moment. But in the larger structure, It is already there. Complete. Now this is not something you feel, not something you perceive, but it is something the equations suggest, which leads to a strange idea. Those final seconds of consciousness, the fading vision, the loss of awareness, they are not just events that occur and disappear. They are part of a structure, a pattern in space-time, and your experience of them is just one way of moving through that pattern. Now we have to be careful, because it's easy to take this too far, to turn it into something philosophical, something emotional, something comforting or disturbing. But physics itself stays neutral. It tells you how time behaves, how events are arranged, how different observers relate to them. It does not tell you what it means. And that's where we are now. At the boundary, we understand what happens to your body, how space affects you, how time itself complicates the idea of survival. But there is one final layer, because everything we've described so far assumes something, that you are just a body in space, a system of matter responding to physical laws. But that's not how you experience yourself. You experience yourself as awareness, as a point of view, as something that observes. So the final question is not, how long does your body survive? It's, what happens to your experience as your body stops working? And that is where physics begins to reach its limit. In the final part, we're going to go there. Not beyond physics, but right to its edge. The moment you disappear. Up to now, we've been talking about your body. Pressure, oxygen, temperature, radiation, all measurable, all predictable. All things physics can describe with equations. But none of that is what you actually experience. You don't experience pressure. You don't experience oxygen levels. You don't experience radiation directly. You experience something else. You experience being aware. And now we have to ask a different question. Not, how long does the body survive? But, how long does the experience last? Because those are not the same thing. Your body can continue functioning for a short time after you lose consciousness. Cells can still be alive. Your heart might still beat. Chemical processes continue. But your experience, your awareness can stop much earlier. So let's go back. You step into space. Seconds pass. Your lungs empty. Your blood begins to lose oxygen. At first, you are aware. You can think. You can observe. You can feel that something is wrong. But then something subtle begins to happen. Your thoughts slow down. Not dramatically, not like flipping a switch, but gradually it becomes harder to form clear ideas, harder to focus, harder to hold on to a single line of thought. This is not panic, not exactly. It's more like confusion. Your brain is not receiving enough oxygen to maintain normal function. And the brain is very sensitive to this. Even a small drop in oxygen changes everything. Vision narrows. You don't lose sight instantly. You lose the edges first. Peripheral vision fades. The center remains for a moment, like looking through a tunnel. Couleurs dim, contrast fades. Details become harder to distinguish. And at the same time, your sense of time begins to break. Moments don't feel continuous anymore. They feel fragmented, disconnected. You might have a thought and then lose it halfway through. You might try to focus and find that you can't hold the idea long enough to complete it. This is the edge. The point where awareness is still present, but no longer stable. Now here's something important. There is no moment where you feel yourself dying. There is no clear boundary. No instant where you say, this is it. Because the process that allows you to recognize that moment is the very thing that is failing. You cannot fully experience the loss of your own experience. So instead, what happens is this. Awareness fades, not like a light switching off, but like a signal losing strength, clear, unclear, focus scattered, present distant, and then nothing. Not darkness, not silence, because those are still experiences, just absence. And this is where physics reaches a boundary, because everything we've described up to now, the loss of oxygen, the failure of neural activity, the breakdown of systems, can be measured, predicted, modeled. But the moment awareness disappears, there is nothing left to measure from the inside. From the outside, we can say, the brain is no longer active, the system has stopped. But from the inside, there is no report, no observation, no final experience. And that creates a strange asymmetry. We can describe everything leading up to that moment in incredible detail, but we cannot describe the moment itself, because description requires an observer. And at that point, there is none. Now, step back, because something very strange has happened. We started with a physical question. How long could you survive in space? And we ended up here, at the edge of experience, where physics can describe the body, but not the awareness inside it. Where we can calculate the timeline, but not the final moment. Where we can explain everything except what it actually feels like to stop. And that's not a failure of physics. It's a boundary. The point where the tools we use to understand the universe no longer apply. Now here's the most unsettling part. From the outside, the process looks continuous. A body losing function, a brain shutting down, a system coming to an end. But from the inside, there is no end, because there is no final moment experienced as final. There is only the last moment you are capable of experiencing, and then nothing follows. Not because something comes after, but because there is no longer a perspective from which after exists. This is difficult to think about, because our minds are built to imagine sequences, before, during, after. But in this case, the sequence breaks. There is a before, there is a during, but the after is not something you experience. Now we've reached the edge. We understand what happens to the body, how the environment affects you, how time behaves, how awareness fades. But there is one final step, because everything we've described so far has been about limits. Limits of the body, limits of time, limits of awareness. In the final part, we're going to bring it all together. Not to go beyond physics, but to see what it actually tells us. What this scenario reveals, not just about survival, but about what it means to exist at all. The silence that remains. Let's return to the question. How long could you survive in space? Really? At first, it sounded simple. A number, 10 seconds, 15 seconds, maybe a minute. But now you see something else. Survival is not just a number. It's a process, a gradual separation between what your body is doing and what you are able to experience. Your body doesn't stop instantly. It continues. Cells react. Systems fail. Heat dissipates. Structure changes. But your experience ends much earlier. And that's the strange part. The universe continues. Space continues. Physics continues. But from your perspective, everything stops. Not because something dramatic happens. Not because there is a final event. But because the process that allows you to observe events is no longer there. And this reveals something deeper. We often think of ourselves as separate from the universe, as observers, as something watching reality from the outside. But in this situation, that idea breaks. You are not separate. You are a process inside the system, a pattern of matter and energy that only exists as long as it can maintain itself. And when the conditions disappear, so does the process. Not violently, not dramatically, just quietly. Now think about space again. It doesn't chase you. It doesn't pull you apart. It doesn't want anything. It simply removes what you depend on. Air, pressure, protection. And without those, you don't survive. Not because space kills you, but because nothing sustains you. That's the real answer. How long could you survive in space? Long enough for your body to begin failing. Short enough that you never fully experience it. And in that gap between what happens and what you can perceive is where the answer lives. Now step back one final time. Everything we described, the loss of pressure, the fading of awareness, the silence, is not unique to space. It's just more obvious there, because space removes all the distractions, all the layers that normally protect you. On Earth, you are surrounded by systems that keep you alive. Air, temperature, gravity, ecosystems. So you don't notice how fragile the process really is. But in space, that illusion disappears, and you see something clearly. Life is not a fixed thing. It's not a permanent state. It's a balance, a set of conditions, a continuous process. And when that balance is broken, the process stops. Not because something dramatic happens, but because nothing continues it. Now here's the final thought. If you were floating in space and you had no clock, no one to tell you what was happening, you would never know how long you survived. You would only know the last moment you experienced. And from your perspective, that moment would not feel like an ending. It would just feel like the last thing that happened. And then nothing follows. Not darkness, not silence, just the absence of experience. And everything else, the drifting body, the radiation, the cold of space, continues without you. That is the answer. Not dramatic, not loud, not cinematic, just quiet and completely real. Done.